Welcome to Study Loop.
So this is now the question about converting a galvanometer into ammeter and voltmeter. So to do this, it is given that the resistance of galvanometer coil is 25 ohms. So let me write it here. Rg equals to 25 ohm. And the current required for full scalification, so the maximum current that can flow through the galvanometer, that is Ig, is equal to 500 microamperes. Okay. Now show in a diagram. So first, for the first part, we have to show this in a diagram. How can we convert? So we can convert a galvanometer. So here is a galvanometer, okay, and this galvanometer has resistance Rc, and the maximum current that can flow on this galvanometer can flow through this galvanometer is Ig. Now this should measure a current, a bigger current, right? And the bigger current, okay, the bigger current that we need to measure is 20 milliamperes, right? Now what we should do, so we cannot send 20 milliamperes through this, right? The galvanometer will not read that. Galvanometer can read a maximum of Ig, so we have to divert the current, like some part of the current should be diverted. So for that we need to use, if we can send I here, so we cannot send this whole I to Z, so we need to divert this current, right, by using because since we need to divert more current, so we need very less resistance, and that less resistance is called shunt, right? And it is denoted by S. So by using a shunt we can divert the current, and we can only have very low current flowing through the galvanometer, and we can finally measure what I is by looking at Ig, right? So what should be the shunt S? Now this should be how much? This should be I minus Ig, right? Now from this equation, if the galvanometer and the shunt are in parallel, so what we can write is Ig Rg should be equal to I minus IGS, right? So to find S, we can write S equal to IGRG upon I minus IG. Now what is IG here? 500 microamperes, so 10 to the power minus 6. What is RG? 25 upon, what is I? 20 milliamperes, so 20 into 10 to the power minus 6 minus 3. And what is Ig? 500 into 10 to the power minus 6. So finally this should give me the value of shunt, and that is equal to 0.641 ohms. So in this way we can use the galvanometer into an ammeter, convert into an ammeter. Now for the second part, how can we convert the galvanometer to a voltmeter reading 500 millivolt full scale and compute their series resistance? So to do that, well, we have to compute a voltage V of 500 millivolts, right? But we cannot again send current more than Ig to the galvanometer, right? So since the current that can maximum flow through galvanometer is Ig, we need to make sure that the current is small, and that will be only possible if the resistance of the circuit is high. So to make that high, we add a resistance here, R, right, so that less current flows through the galvanometer, and the potential across this should be 500 millivolts, right? Right. Now to do that, what we can say, is Ig times the resistance of galvanometer plus the resistance that we added should be equal to V. Now what is Ig? 500 micrometers. 500 into 10 to the power minus 6 times what is Rg? The resistance of a galvanometer is it small g? We supposed is small g before. So 25. Now what is R? That is what we need to find out. And what is V? That is 500 millivolts. So 500 into 10 to the power minus 3. Now solve this equation. You get the resistance that has to be added equals to 975 ohms. Alright, so this is how you convert a galvanometer into a voltmeter. So this is the solution to this question.